JavaFX public APIs and scene graph in JavaFX. Now we are focusing on JavaFX public APIs and scene graph. JavaFX public APIs, the top layer of the JavaFX architecture, provides a complete set of public APIs that support rich client application development. These APIs provide unparalleled freedom and flexibility to construct rich client applications. The JavaFX platform combines the best capabilities of the Java platform with comprehensive immersive media functionality into an intuitive and comprehensive one-stop development environment. Scene graph. The JavaFX scene graph is the starting point for constructing a JavaFX application. It is a hierarchical tree nodes that represent all of the visual elements of the application's user interface that can handle it can handle input and can be rendered. Here you can see a JavaFX application lifecycle. The entry point for JavaFX applications is the application class. The JavaFX runtime does the following in order whenever an application is launched. 1. Construct an instance of the specified application class, calls the init method. 3. Step 3 calls the start JavaFX.stage method. Stage 4 wait for the application to finish, which happens when either of the following occur. The application calls platform.exit method. The last window has been closed and the implicit exit attribute on platform is true. Step 5 calls the stop method. Note that start method is abstract and must be overridden. The init and stop methods have concrete implementations that do nothing. Calling platform.exit method is the preferred way to explicitly terminate a JavaFX application. Directly calling system.exit int method is an acceptable alternative but doesn't allow the application stop method to run. A JavaFX application should not attempt to use a JavaFX after the FX toolkit has terminated or from a shutdown hook, that is after the stop method returns or system.exit int method is called. Here you can see launch is connected to init, and init is connected to start, and start is connected to stop. Here you can see root, branch, and leaf nodes. This figure shows a general inheritance diagram of root, branch, and leaf nodes. The root node has 2 leaf nodes and 1 branch node. The branch node has 2 leaf nodes. The JavaFX scene graph API makes graphical user interface easier to create, especially when complex visual effects and transformations are involved. A scene graph is a tree data structure most commonly found in graphical applications and libraries such as vector editing tools, 3D libraries, and video games. The JavaFX scene graph is a retain mode API, meaning that it maintains an internal model of all graphical objects in your application. At any given time, it knows what objects to display, what areas of the screen need to repainting, and how to render it all in the most efficient manner. Instead of invoking primitive drawing methods directly, you instead use the scene graph API and let the system automatically handle the rendering details. This approach significantly reduces the amount of code that is needed in your application. The individual items held within the JavaFX scene graphs are known as nodes. Each node is classifies sorry. Each node is classified as either a branch node, meaning that it can have children, or leaf node, meaning that it cannot have children. The first node in the tree is always called the root node, and it never has a parent. Here you can see the root node here, and root node is connected to leaf nodes and a branch node here, and branch node is connected to leaf nodes here. Here you can see the scene graph consists of a window, stage, scene, and its nodes. A scene describes everything that is inside a window in a JavaFX application, where the window provides a look and feel that's specific to the OS that's driving the application. The scene is completely yours to style and change. The window that most people will use is a stage, which extends the window class. Each of these concepts, stage, scene, stage scene graphs and nodes surround the scene object, and together they discharge the responsibility of rendering your application to the screen. Stage. The stage represents the window of any view in the JavaFX model. In fact, it extends the window. Scene graph. The scene graph in JavaFX represent the contents of a scene that focuses on the hierarchical relationship between nodes. Prism rendering scene graph. Alongside the scene graph, we get to see and modify. JavaFX maintains a sister scene graph and uses this to determine almost other things. How much of the scene has changed and which areas of the scene need updating. The textures required to render the scene and the rendering of the scene. Part of the reason that the JavaFX scene can be so efficient is that it caches and unchanged elements of a scene, so they don't need to be recomputed unnecessarily. Nodes. Nodes are the foot soldiers of a user interface. From charts to images, layouts, to shapes, they all extend the node class in some way. The node is the basic interface component that has bounds, layout position, event handling, mouse, keyboard, etc., opacity and transforms. All other UI elements layer functionality on top of the node class. Scene is responsible for four things: holding a reference to the parents that hold the scene nodes, that is most often a layout of some type, but can be a group. Optionally controlling the size of the window that can be delegated to the root node, but doesn't have to be. Setting default higher level rendering properties, useful for 3D scenes and the camera also for 3D. Triggering event handling behind the scenes. For each of these things impacts how the scene works and how it needs to be defined. For instance, because the scene will hold your scene graph, it must to be defined with the root node. Anti-aliasing and depth testing corresponds to higher level rendering properties, which can be set as default for this the scene. Here you can see nodes must belongs to a group or layout parents. Nodes are connected to scene. Nodes interacts with scene. scene holds all nodes in a parent and directs events. Scene interacts with stage. Stage extends window, handles UI centric styling and behavior. Here you can see JavaFX scene graph. A scene graph is a tree data structure that arranges and groups graphical object for easier logical representation. It also allows the graphics engine to render the object in the most efficient way by fully or partially skipping object which will not be in the final image. The following figure shows an example of a JavaFX scene graph architecture. At the very top of the architecture is a stage. A stage is a JavaFX representation of a native OS window. At any given time, a stage can have a single scene attached to it. A scene is a container for the JavaFX scene graph. All elements in the JavaFX scene graph are represented as nodes, as node objects. There are three types of nodes: root, branch, and leaf. The root node is the only node that doesn't have a parent, and is directly contained by a scene, which can be seen in the figure here. The difference between branch and a leaf is that a leaf node does not have children. In the scene graph, many properties of a parent node are shared by the child nodes. For instance, a transformation or an event applied to a parent node will also be applied recursively to its children. As such, a complex hierarchy of nodes can be viewed as a single node to simplify the programming model. Here you can see a stage. Native window interacts with scene interacts with root node interacts with leaf nodes, and branch node. Here branch node interacts with leaf nodes. Here you can see the module structure. Here we focuses on the JavaFX user facing programming interface. All standard components, controls, and other auxiliary classes are organized as standard JPMS module since Java 9. Each module defines its build dependencies. For instance, JavaFX.base package is always imported by all other JavaFX modules. The module structure allows separating platform-specific functionality. For example, iOS, x86 PC, and heavyweight extra controls not required by every type of application. For example, web browser, media player. Note, while the AWT and previous AWT and Swing frameworks are included in the standard Java distribution, for example OpenJDK, JavaFX has been distributed as a separate project since Java 9. The most obvious sequence of this is having a build configuration is practically required, while previously just importing the GUI classes was sufficient. Since the OpenJFX 16, even loading JavaFX classes using legacy class path is discouraged. Thus, the easiest way to package JavaFX programs is by using build system and JavaFX plugin. Next we will discuss, we will take a bit more detailed look at each module. JavaFX.base. The base module contains classes related to reactive programming, event handling, and miscellaneous auxiliary classes, for example, the type for time durations. These classes are essential for event-based and asynchronous programming in general. JavaFX.beans.asterisk wrappers for reactive values and handling of values. JavaFX.collections.asterisk wrappers for collections with reactive properties, react to operate such as insertion or deletion. JavaFX.event.asterisk generic event handling infrastructure. JavaFX.util.asterisk helpers and transformers, for example, duration. JavaFX.controls. The control module contains a standard set of 208 plus active component for forms. JavaFX.scene.chart.asterisk special components for data visualization, for example, bar or pie chart. JavaFX.scene.control.asterisk standard components extend scene.control.control, visual representation implement scene.control.skin. Some more geared towards model view control MVC paradigm, for example, the ones with model in the class name. Typical class hierarchy for controls: object, then scene.not, then scene.parent.scene. Then scene.layout.region, then scene.control.control, then component X. Visit the API documentation or play around with scene builder to find visual example for components. Common IDE with auto completion help a lot when writing controller code for the component. Note some component employ generic types to ensure safe access to data. Due to the way generics are implemented in Java, generic types should not be nested. For example, type A, then less than sign, then type B, then type C, as the compiler cannot guarantee correct behavior for these values at time. If there is a need for generic nested generic type, simply create a new class that extends from that type. In generic, static types in Java do not prevent incorrect use of null values, but can eliminate other incorrect use of types. In Kotlin, even incorrect uses of null values can be eliminated. JavaFX.fxml. The fxml module contains classes for interfacing with fxml files built with scene builder. At fxml, annotation for exposing a private protected member in controller class to the fxml routines. Fxml loader, used for loading .fxml files, instantiating the scene and building to a controller. JavaFX.graphics. The graphics module contains a standard set of classes. One manipulating the scene graph, for example, layout, forms, transformation, painting, image and pixel manipulation, effects, printing, animations, etc. JavaFX. Animation, CSS, geometry. JavaFX.print, print into a paper. JavaFX.scene, general purpose classes plus cameras and lights. JavaFX.scene.effect or paint, theming and visuals. JavaFX.scene.canvas or image or shape or text, graphics element. JavaFX.scene.input, event handling, concrete event types. JavaFX.scene.robot, UI testing. JavaFX.scene.layout, dealing with windows, dialogues and scenes, window contents. JavaFX.application plus others. JavaFX.stage.file chooser, pop-up, scene, stage, window, plus others. 3. Coordinating concurrent task, JavaFX.concurrent colon task service worker. JavaFX.media. The media module contains the standard set of classes for the playback of video and audio, audio clip, playback of audio, audio equalizer, graphic equalizer, media resources, media player, playback controls, media view components, dash track components, handle the distinct streams of sound, video, and subtitles, etc. in a media file or source. JavaFX.swing. The swing module provides the compatibility layer for the legacy swing AWT code. The main purpose of these classes is to either enable the use of old component in a JavaFX application or to support extending a legacy application with new component. JFX panel for displaying JavaFX content in a Swing app. Swing FX utils, tools for transforming between, for example, different bitmap formats. Swing node for displaying swing contents in a JavaFX app. JavaFX.web. The web module contains a set of WebKit based component for displaying web component in JavaFX application. HTML editor, web engine, background object manages the web page and session, web event, web specific event, web view, the visual control component for displaying the web content. Monocall, the default graphics pipeline backend will refuse to launch a JavaFX in, for example, GTU's GitLab CI CD. In order to run JavaFX programs headless, the monocall framework is required. Here the module JavaFX.base defines the base API for the JavaFX UI toolkit, including APIs for binding, properties, collections, and events. Here the module JavaFX.graphics defines the core scene graph defines the core scene graph APIs for JavaFX UI toolkit, such as layout, containers, application lifecycle, shapes, transformations, canvas, input, painting, image handling, and effects, as well as API for animation, CSS, concurrency, geometry, painting, and windowing. Note the JavaFX classes must be loaded from the set of named JavaFX.asterisk modules on the module path. Loading the JavaFX classes from the class path is not supported. Module JavaFX.media defines APIs for playback of media and audio content as part of the JavaFX UI toolkit, including media view and media player. Module JavaFX.swing defines APIs for JavaFX swing interop support included with the JavaFX UI toolkit, including swing node for embedding swing inside the JavaFX application, and JavaFX panel for embedding JavaFX inside the swing application. Module JavaFX.control defines a UI control chart and skins that are available for JavaFX UI toolkit. Module JavaFX.web defines APIs for web view functionality contained within the JavaFX UI toolkit. Module JavaFX.fxml defines the fxml APIs for JavaFX UI toolkit. Here JavaFX media is connected to JavaFX base. Here JavaFX media is connected to JavaFX graphics. Here JavaFX swing is connected to JavaFX.graphics, and JavaFX.web is connected to JavaFX graphics and JavaFX base and JavaFX.control. JavaFX.controls is connected to JavaFX graphics and JavaFX base. JavaFX.graphics is connected to JavaFX base. Here JavaFX.fxml is connected to JavaFX.base. Now we are considering JavaFX application structure. JavaFX application is divided hierarchically into the three main components known as stage, scene, and nodes. We need to import JavaFX.application.application class in every JavaFX application. This provides the following lifecycle method for JavaFX application: public void init method, public hashtag void start stage primary stage method, public void stop method. In order to create a in order to create a basic JavaFX application, we need to import JavaFX.application.application into our code, inherit application into our class, override start method of application class. Stage is stage in a JavaFX application is similar to a frame in a Swing application. It acts like a container for all JavaFX objects. Primary stage is created internally by the platform. Other stages can further be created by the application. The object of primary stage is passed to start method. We need to call show method on the primary stage object in order to show our primary stage. Initially, the primary stage look like however, we can add various objects to this primary stage. The objects can be added in a hierarchical way. That is, first scene graph will be added to this primary stage. Then that scene graph may contain nodes. A node may be any object of the user's interface, like text area, button shapes, and text area, button shapes, media, etc. Scene actually hold all the physical contents nodes of the JavaFX application. Scene class provide all the methods to deal with the scene object. Creating scene is necessary in order to visualize the content of the stage. At once instance, a scene object can only be added to one stage. In order to implement scene in our JavaFX application, we must import JavaFX.scene package in our code. The scene can be created by creating the scene class object and pass the layout object into the scene class constructor. Scene graph exists at the lowest level of the hierarchy. It can be seen as the collection of various nodes. A node is an element which is visualized in the stage. It can be any button, text box layout, image, radio button, checkbox, etc. Nodes are implemented in a tree kind of structure. There is always one root in the scene graph. This will act as a parent node for all other nodes present in the graph. However, this node may be any of the layout. This node may be any of the layouts available in the JavaFX system. Leaf nodes exist at the lowest level in the hierarchy. Each of the node present in the scene graph represent the classes of JavaFX.scene package. Therefore, we need to import the package into our application in order to create a full featured JavaFX application. Class stage. The JavaFX stage class is the top level JavaFX container. The primary stage is constructed by the platform. Additional stage object may be constructed by the application. Class scene. The JavaFX scene class is the container for all content in a scene graph. The background of the scene is filled as specified by the fill property. Class node in package JavaFX.scene. Base class for scene graph nodes. A scene graph is a set of three data structures where every item has a 0 or more parents, and each item is either a leaf with 0 sub items or a branch with 0 or more sub items. The class shape 3D in package JavaFX.scene.shape. The shape 3D base class provides definitions of common properties for objects that represent some form of 3D geometric shapes. These properties include the material to be applied to the fillable interior of the shape or the outline of shape. And next point, the draw model properties that define how to render its geometry. Next point, the face culling properties that defines which face to cull. Note that this is a conditional feature. Class parent, the base class for all nodes that have children in the scene graph. The class region in package JavaFX.scene.layout. The region is a base class for all JavaFX node-based UI controls and all layout containers. It is a resizable parent node which can be styled from CSS. It can have multiple backgrounds and borders. It is designed to support as much of the CSS3 specification for backgrounds and borders as is relevant to JavaFX. The full specification is available at the W3C. Class pane in package JavaFX.scene.layout. The base class for layout panes which need to expose the children list as public so that users of the subclass can freely add or remove children. Class control in package JavaFX.scene.control. The base class for all user interface controls. A control is a node in the scene graph which can be manipulated by the user. Controls provide additional variables and behaviors beyond those of the nodes to support common user interactions in a manner which consist and predictable to the user. The class shape in package JavaFX.scene.shape. The shape class provides definitions of common properties for objects that represent some form of geometric shape. These properties include a paint to be applied to the fillable interior of the shape, a paint to be applied to the stroke, the outline of the shape, the decorative properties of the stroke including the width of the border stroke, whether the border is drawn as the interior padding to the edges of the shape as an interior etching edges of the shape as an interior edging of the that follows the inside of the border, or as a wide path that follows along the border striding it equally both inside and outside. Decoration styles for joints between path segment and unclosed ends of path, and dashing attributes. Here you can see the stage here. Scene is inside the stage and scene graph is inside scene. Inside the scene graph you can see nodes. Root node interacts with branch node, and here leaf node, and branch node interacts with leaf nodes. Here node, here you can see node contains subclasses 3D shape 3D parents and shapes, and parents contain a subclass region, and region contains subclasses pane and control. Here you can see a CSS style sheet sample. This image contains two screen captures of the same UI controls but with different CSS style sheets applied. The left screen uses the style sheet that defines the background color as gold and the UI control as a lighter gold. The font for the controls is a sans serif font in black. The two custom buttons are oval shaped and light gold color. The first button labeled accept in the green font. The second button is labeled decline in the red font. To the right of the buttons is a label not available. By contrast, the right screen uses a style sheet that defines a background color as light olive and the UI control as a medium olive. The font for the control is a Courier New font in dark gray. In this version of UI, the accept and decline buttons have both standard rectangular shape, but the border of the buttons is a dark gray and the font color is a medium green, and the labels fills the buttons with minimal space between the label and the edge of the button. The not available and progress labels have a dash line border around them. A font of a complete assessment of type of the one size and face includes caps, small caps and lowercase, punctuation marks as accent and commonly used symbols. It contains alphabets in Roman and italic capitals and boldface. Thus, the Courier New typeface is 12 point size is a font, but Courier New is a typeface. Font and typefaces don't come with colors. The color is a function of the printing process. Sans serif and serif are contrasting styles, and proportional and monospace are contrasting styles. JavaFX cascading style sheet CSS provide the ability to apply customized styling to the user interface of JavaFX application without changing any of that application's source code. CSS can be applied to any node in the JavaFX scene graph and are applied to the nodes asynchronously. JavaFX CSS styles can also be easily assigned to the scene graph at runtime, allowing the application appearance to dynamically change. This figure demonstrates the application of two different CSS styles to the same set of UI controls. JavaFX CSS are based on the W3C CSS version 2.1 specification with some additions from the current work on version 3 and newer versions also. The JavaFX CSS support and extensions have been designed to allow JavaFX CSS style sheets to be passed cleanly by any compliant CSS parser, even one that does not support JavaFX extensions. This enables the mixing of CSS style for JavaFX and other purposes, such as HTML pages into a single style sheet. All JavaFX property nodes names are prefixed with the vendor extension of -fx-, including those that might seem to be compatible with the standard HTML CSS because some JavaFX values have slightly different semantics. Here you can see a JavaFX UI control sample. The illustration shows a sample UI and JavaFX UI controls. The controls are presented in rows. Each row correspond to a particular type of UI control. Top row contains 4 buttons. The left button in the row has cancel option, a cancel caption on it. The next button has neither a caption nor a graphics. Third button has both caption and graphics. The fourth button has the cancel caption and is highlighted. The second row shows toggle button. Left toggle button has the first caption. On it, the next button has the second caption and looks pressed. The third button has the third caption on it. Fourth button has no caption. The rightmost button in the row has a long description that reads long and really long. Third row contains two hyperlinks. First hyperlink has only the textual caption, "Hello, I am a hyperlink." The second hyperlink has both an icon and the text caption. I have an icon too. Fourth row present three checkboxes. Left checkbox is not selected and has the caption, "Hit me, dude." The center checkbox is the undefined state and has the caption, "Are you sure?" The right checkbox is the selected state and has the caption, "There you go." Fifth row shows two radio buttons. Left radio button is unselected and has the caption "Bye." The right radio button is selected and has the caption "Hello." The sixth row contains menu buttons. The left button has a down arrow that indicates that the menu expands downwards. The right button has the right arrow that indicates that menu expands right side. The seventh row shows the scroll window view component. It presents a scrollable area with both vertical and horizontal scroll bars. Eighth row presents two progress bars. First progress bar indicates progress of approximately 25%. The second bar is the indefinite state. Ninth row shows the progress indicator in the indeterminate state. 10th row present two list view component. The left list view has a vertical scroll bar. Following elements: item 0, item 1, item 2, item 3, item 4. The second list view has a horizontal scroll bar and list following the element 7, 8, 9, 10, 11. The JavaFX UI controls available through the JavaFX API are built by using nodes in the scene graph. They can take a full advantage of visually rich features of the JavaFX platform and are portable across different platforms. JavaFX CSS allows for theming and skinning of the UI controls. This figure shows some of the UI controls that are currently supported. New Java UI controls like title pane or accordion have been introduced with the JavaFX SDK. The new controls reside in the javafx.scene.control package. For more details, information about all the available JavaFX UI controls, see JavaFX UI controls document in the API and the API documentation for the javafx.scene.control. The class button, a simple button control. Button control can contain text or a graphic. Button control has three different modes: normal push buttons, default. The default button is rendered differently to make the apparent to users that there should be the default choice should be. They can be unclear as to what should be selected. The behavior of the default button differs depending on the platform in which represented. In Windows and Linux, the default button receives an enter key presses when it has the focus. When the default button does not have the focus, the focus is on another button control, the enter key press will be received to the other non-default button. When the focus is elsewhere in the user interface and not on any button, the enter key press will be received by the default button if one is specified, or if no other node in the scene consumes it first. In Mac OS X, the default button is the only button in the user interface that responds to the enter key press. If focus is on another non-default button, the enter is pressed, the event is only received by the default button. On Mac OS, the only way to fire a non-default button is through space key. The cancel button is the button that receives keyboard VK underscore ESC press if no other node is in the scene consumes it. Toggle button. The class toggle button. The toggle button is a specialized control which has the ability to be selected. Typically, a toggle button is rendered similarity to a button. However, there are two different types of controls. The button is a command button which invokes a function when clicked. A toggle button is, on the other hand, is simply controlled with a boolean indicator whether it has been selected. Class hyperlink, an HTML-like label which can be a graphic and or text which responds to rollovers and clicks. When a hyperlink is clicked or pressed is visited becomes true. A hyperlink behaves just like a button. When a hyperlink is pressed and released, an action event is sent, and your application can perform some action based on this event. Class checkbox. A tri-state selection control typically is skinned as a box with the check mark or tick mark when checked. A checkbox control can be in one of three states: checked, indeterminate, false, checked true. Intermediate equal false and checks equal true. Unchecked, indeterminate equal false and check equal false. Undefined, indeterminate equal true. If checkbox is checked, then it is also by definition defined. When checked, the checkbox is typically rendered with the check or tick mark. The checkbox is in this state is selected is true and indeterminate is false. The class radio button. The radio buttons create a series of items where only one item can be selected. Radio buttons are a specified toggle button. When radio button is pressed and released, an action event is sent. Your application can perform some action based on this event by implementing an event handler to process the action event. Class menu button. Menu button is a button which, when clicked or pressed, will show a context menu. The menu button shares a very similar APIs to the menu control, insofar that you set the items that should be shown in the items observable list, and there is a text property to specify the label shown within the menu button. Progress bar. The class progress bar, and specialization of the progress indicator, which is represented as a horizontal bar. The class progress indicator, a circular controller which is used to indicate for indicating progress, either infinite, also known as indeterminate, or finite, often used with the task API for representing progress of background tasks. A list view. The class list view T. A list view displays the horizontal or vertical list of items from which the user may select or which the user may interact. A list view is able to have its generic type set to represent the type of data in the backing model. Doing this has the benefit of making various methods in the list view as well as supporting classes mentioned, supported classes type shape. In addition, making use of generic type supports substantially specified development of applications making use of list view, as all modern IDEs are able to autocomplete far more sufficiently with the additional type information. Here you can see buttons, and here toggle buttons and hyperlinks here. Checkbox normal, undefined and selected. Radio buttons, menu buttons, scroll view, progress bar, progress indicator is indeterminate, list views here. Here you can see a simple JavaFX application. The class application class from which JavaFX applications extend. This class is in package javafx.application. As an example 2, we can consider JavaFX application lifecycle here. Launch a standalone application. This method is typically called from the main method. It must not be called more than once, or an exception will be thrown. This is equivalent to launch the class.class args, where the class is the immediately enclosing class of the method that called launch. It must be a subclass of application, or a runtime exception will be thrown. Launch method does not return until the application has exited, either via a call to platform.exit, or all of the application windows have been closed. Init the application initialization method. This method is called immediately after the application class is loaded and constructed. An application may override this method to perform initialization prior to the actual starting of the application. The implementation of this method provided by the application class does nothing. Note, this method is not called on the JavaFX application thread. An application must not construct a scene or a stage in this method. An application may construct other JavaFX objects in this method. Start This method is called when the application should the main entry point for all JavaFX applications. The start method is called after the init method has returned and after the system is ready for the application to begin running. Note, this method is called on the JavaFX application thread. Stop. This method is called when the application should stop and provide a convenient place to prepare for application exit and destroy resources. The implementation of this method provided by the application class does nothing. Note, this method is called on the JavaFX application thread. Here you can see add an exit button to the scene here. As an example 3, we can consider JavaFX.scene package. Provides the core set of base classes for the JavaFX scene graph API. As an example 4, we can consider adding a leaf node. Class scene, the JavaFX scene class is the container for all the content in a scene graph. The background of the scene is filled as specified by the fill property. The class scene is in JavaFX.scene package. The important points to consider in this example are as follows. The main class is an extension of the JavaFX.application class. Its start method is overridden. In this case, overridden and receives a stage object, a top level GUI container as its only parameter. The root node, in this case, an instance of the JavaFX.scene.group class is created and passed to the scene constructor along with the scene's width, height, and fill. The stage title scene and visibility are all set. The main method invokes the application.launch method. The blue rectangle leaf node that is 250 multiplied by 250 pixels will appear at the specified x and y coordinates. By default, x increases from left to right and y increases from top to bottom. This can be affected by transformations. However, this figure shows the results of adding a leaf node. As an example 5, we can consider this one as adding leaf nodes. Class scene here, the JavaFX scene class is the container for all content in the scene graph. The background of the scene is filled with as specified by the fill property. The node, the class node is the base class for scene graph nodes. A scene graph is a set of tree data structures where every item has a 0 or 1 parents. And each item is either leaf with 0 sub items or a branch with 0 or more sub items. This is scene and node class nodes are in package JavaFX.scene. Here the class circle is a subclass of class shape, and class shape is a subclass of class node. Here the class text is a subclass of class shape, and class shape is a subclass of class node. Here you can see a push integration. Here the method void run later runnable. The run the specified runnable in on the JavaFX application thread at some unspecified time in the future. The push communication is a request response style of communication without the request part. The application server can push out data at any time. The Java Message Service JMS, WebSockets and memory grids come with a fire and forget style notification mechanism and can be easily integrated with JavaFX. JSR 356 implements the WebSocket protocol, is a part of Java EE7 and comes with the Java Client API. The WebSocket specification introduces a bidirectional binary protocol and is perfectly suitable for integration of UI clients, WebSocket messages. UI clients. WebSocket messages can have a binary or text nature and are received with an endpoint subclass as shown here. As an example, we can consider this illegal state exception. If this method is called more than once, the method we consider here is void launch string ... args in class application. As an example 2, we can consider null point exception. If root is null in constructor scene parent root double width double height boolean depth buffer in class scene. Now we are considering module JavaFX.base defines the base API for the JavaFX UI toolkit, including APIs for binding, properties, collections, and events. As an example 8, we are considering module JavaFX.controls defines the UI controls, charts, and skins that are available for the JavaFX UI toolkit. JavaFX.fxml, the module JavaFX.fxml define the fxml APIs for the JavaFX UI toolkit. Module JavaFX.graphics defines the core scene graph APIs for the JavaFX UI toolkit, such as layout, containers, application lifecycle, shapes, transformation, canvas, input, painting, image handling and effects, as well as APIs for animation, CSS, concurrency, geometry, printing and windowing. Note, the JavaFX classes must be loaded from a set of named JavaFX.asterisk modules on the module path. Loading the JavaFX classes from the class path is not supported. Module JavaFX.media defines APIs for playback of media and audio content as part of the JavaFX UI toolkit, including media view and media player. Module JavaFX.swing defines APIs for the JavaFX swing interrupt support included with the JavaFX UI toolkit, including swing node for embedding swing inside a JavaFX application and JFX panel for embedding JavaFX inside the swing application. Module JavaFX.web defines APIs for the web view functionality contained within the JavaFX UI toolkit. Now we are considering overview in scene graph. One possible implementation will produce a scene graph matching the figure above as follows. Scene class scene in package JavaFX.scene. The JavaFX scenes class is a container for all content in a scene graph. The background of all scene is filled as specified by the fill property. The result of running code is seen in this figure. An example of hello world scene graph can be seen in this figure here. The important nodes: a node can have maximum one parent. A node is the active attached to currently visible scene. Scene graph can only be modified from the JavaFX application thread. Now we are considering here string converter, complete code in string with the string converter in choice box in UI controls. The code can be tested in a single .java file. The class choice box in package javafx.scene.control in module javafx.controls. The choice box is used for presenting the user with a relatively small set of predefined choices from which they may choose. The choice box, when showing, will display to the user these choices and allow them to pick exactly one choice. When not showing, the current choice is displayed. Here we demonstrate the choice box. The choice box control is a list of values from which the user makes a selection. In this particular implementation, there is an empty value which makes a selection optional. The following screenshot shows choice box app. A selection furniture is made and save button is pressed. The save button call invokes a println method which prints out the object. Here the choice box printing out selection. The program puts a label, a choice box, and a button into an H box. An action is set on the save button, which print out the value. The simplest usage of choice box is to fill it with strings. This choice box in this article is built on a JavaFX class called pair. Pair is a general container for any key value pair and can be used in place of a domain or other special purpose object. Strings should only be used if they can be used without manipulation or decoded consistently. String converter. When using a complex object to back a choice box, a string converter is needed. This object serializes a string to and from a choice box. For this program, the only toString needs to be coded, which replaces the default toString of the pair. The pair object, both toString and fromString will need an implementation in order to compile. An empty object, empty pair, empty underscore pair is used to prevent null pointer exceptions. The return value from asset class dot get value can be accessed and compared consistently without adding special null handling logic. The choice box is used to select from a list of values. When a list of values is a complex type, provide the string formatter to serialize a list of object into something printable, if possible. If possible, use an empty object rather than null to support optional values. The complete code is here, and the code can be tested in a single .java file. Now here we are considering complete code here in VBox and HBox. In layouts, this is a completed JavaFX application subclass and main. The class VBox in package javafx.scene.layout in module javafx.graphics. VBox lays out its children in a single vertical column. If the VBox has a border and or padding set, then the contents will be laid out within those insects. The class HBox in package javafx.scene.layout in module javafx.graphics. HBox lays out its children in a single horizontal row. If the HBox has a border and or padding set, then the content will be laid out within those insects. The layout in VBox and HBox. Layout in JavaFX begins with selecting the right container controls. The two layouts controls are used most often VBox and HBox. VBox is a container that arranges its children in a vertical stack. HBox arranges its children in a horizontal row. The power of those two controls comes from wrapping them and setting a few key properties. Alignment, hgrow, and vgrow. This article will demonstrate these controls through a sample project. A mock-up of the project shows a UI with the following: a row of top controls containing a refresh button and a sign out hyperlink, a table view that will grow to take up the extra vertical space, and a close button. The UI also features a separator which divides the top part of the screen with what may become a standard lower panel, save button, cancel button, etc. for the application. Here you can see the kind of mock-up. VBox is the container, is the outermost container. VBox, this will be the parent provided to the scene. Simply putting UI controls in this VBox will allow the controls, most notably the table view, to stretch to fit the available horizontal space. The top controls, the refresh button and the sign out hyperlink are wrapped in HBox. Similarly, I wrap the bottom close button in the Xbox Hbox, allowing for additional buttons. This picture shows the mockup broken down by container. The parent's VBox is the outermost blue rectangle. The Hboxes are the inner rectangles, red and green. So this is a mockup broken down. Now we are considering alignment and edge grow. The refresh button is aligned to the left aligned to the left while hyperlink is aligned to the right. This is accomplished using two Hboxes. Top controls is a box. Top controls is a Hbox that contains the refresh button. And the also contains the an Hbox with sign out hyperlink. As the screen grows wider, the sign out hyperlink will be pulled to the right while the refresh button will retain its left alignment. The alignment is the property that tells a container where to position a control. Top controls set alignment to the bottom left. Top right control sets the alignment to the bottom right. The bottom makes sure that the baseline of the text refresh matches the baseline of the text sign out. In order to make sign out hyperlink move to the right when screen get wider, the priority dot always is needed. This is a cue to the JavaFX to widen top right controls. Otherwise the top controls will keep this space, and top right controls will appear on the left. Sign out hyperlink still would be right aligned but in a narrower container. Notice that set hgrow is a static method and neither invoke in on the top controls hbox nor in on itself. Top right controls. This is a this is a facet of the JavaFX API that can be confusing because most of the API sets the properties via setters on objects. The close button the close button is wrapped in the hbox and positioned using the bottom right property. We grow since the outermost container is vbox. The child table view will expand to take the extra horizontal space when window is widened. However, vertically resizing the window will produce a gap at the bottom of the screen. The vbox does not automatically resize any of its children. As with the top right controls hbox, a grow indicator can be set. In the case of hbox, this was a horizontal resizing instruction set hgrow. For the table view container vbox, this will be set vgrow. There are few ways to space out UI controls. Now we are considering margin. This article uses the margin property on several of the containers to add white space around the controls. These are set individually rather than using spacing on the vbox, so that the separator will span the entire width. the insects uh, used by table TBL customers omit any top spacing to keep the spacing even. JavaFX does not consolidate white spaces as in web design. If the top insect were set to 10.0D for the table view, the distance between top controls and the table view would be twice as wide as the distance between any other controls. Notice there are statics method like priority. This picture shows the application when run its initial 800 multiplied by 600 size. This image shows the application resized to a smaller heights and width here. Actually, this one is the resized image to a smaller width here. Select the right containers. The philosophy of JavaFX layout is the same as the philosophy of Swing. Select the right container for the task is at hand. This article presented the most versatile containers, VBox and HBox. By setting properties like alignment, hgrow and hgrow and vgrow, you can build incredibly complex layout through nesting. These are the containers I use the most and often are the only containers that I need. The complete code here, the code can be tested in a pair of .java files. There is a pocho for the customer object used by the table view. This is a completed JavaFX application, subclass and main. Now we are considering MVVM pattern in application structure. Here you can see the view, the employment request view dot class. The MVVM pattern, the model view, the model view model MVVM is a software architecture that separates UI controls, the view, from data access and business logic, the model. The separation helps large applications during the maintenance phase. With the MVVM, view changes, especially those that are purely cosmetic, can be made without fear of introducing side effects. Changes to the model, usually less volatile than the view, can be applied more easily throughout the application because MVVM promotes reuse. In between the view and the model is the view model. The view model mediates between view and the model, yet contains no references to the view. This enables view model sharing, which is useful when two views show similar data. This article, here we present a simplified MVVM example. An employment request form submits several data elements to backend service. This screenshot shows the application with the same with the name, position, and annual salary data element set. This is the figure employment request form here. Entering data and after entering data and pressing save, the model object responds with a println. The program output here you can see. If the reset button is pressed after filling in the text fields, the form is restored to its original value, empty name and position and an annual salary of 0. The cancel button ends the application. The app, the main entry point, view UI controls, model function calls to the business logic and data access. View model contains screen stage and UI logic. Domain object, UI neutral transfer object. Converter helper class for view model to model communication. This UML shows the structure of of the employment request form. The view class is an employment request view which contains UI control object like the name, text, and like the text field. The view model class is employment request view model and contains JavaFX properties. The model class is the employment request model with a single method for persisting the form. The employment request converter is a helper class. Employment request is a POJO containing data fields. MVVM apps is the main entry point and JavaFX application subclass. UML class model of here UML class model of application view. In MVVM, the view class is responsible for UI controls and nothing else. Event handlers attached to UI controls delegate immediately to the view model. JavaFX data binding updates the UI with model changes. In the employment request form, 3 text fields gather input from the user. TF name, TF position, and TF annual salary. 3 buttons initiate operations on the application: btn save, btn cancel, btn reset. This is the beginning of the employment request view class here. Here the application MVVM app initiates app is connected to employment request via initiate, and employment request view is connected to employment request view model via binding and commands. Employment request model is connected to employment request converter, and employment request view model is connected to employment request model via provider persistent for. And here you can see domain model employment request. The view knows about view model and uses JavaFX binding to synchronize UI with the view model. This demo treats view model as a prototype object created when the view object is created. Alternatively, view model can be a singleton or provided by CDI. Each UI field is bound bidirectionally with the view model. As UI changes, say through entering a value of TF name, the corresponding field of the view model is updated. For more complicated expression for TF annual salary, field is needed to convert a string based text field into double property. Here the employment request view class is continuing here. UI in this demo is built-in code. The following create-view method handles the layout of the form and puts core controls such as tf name, and btn save in containers. Here the employment request view.class is continuing. The class ends with handlers for buttons. These handlers delegate their actions to the view model. Now we're considering here you can see the view model. The view model is a layer that interact with both view and the model. In this simple presentation, the value of such a layer is limited. One could just unpack the text field into model in the button handler. As the UI becomes more complex, it is useful to have a plainer, more business-oriented object to work with. While there is a one-to-one correspondence between view model and view model, that may always be the case. Handling many-to-many relationship is the key for view model. There may be many views that working with the same model element. Multiple models may contribute to a single view. In this view model look like domain object that will be presented later with one key difference. JavaFX binding employment request view model was bound to the employment request view UI controls and methods of employment request view model will have access to all of the information within the save method. No extra marshalling argument is needed. Employment request view model class you can see here. Both the converter and the model have been added to this view model as prototypes, meaning that they were created when the view model is created. The converter is a class that translates between view model view model and a domain object. In this app there is a single toEmployee request method that create an object from the view model fields. Here you can see employment request converter.class. The model finally the model persists the information. This model example has a single method which verify that it receive correct data for save operation. Employment request model class, here you can see it. This is the plain Java object used to transport data from model to UI. JavaFX provides developers uh, with a powerful toolkit to build applications. However, design is still needed for an effective program. MVVM is architectural patterns that separates the pure UI class UI classes called views from pure data classes called models. In the middle sits the view model, which relies heavily on the data binding in JavaFX. Further work, sometimes view needs to know of a model change because MVVM dictates a one-way control flow, view to view model to model and not the reverse. The difference mechanism than data binding is needed to make view model aware of model changes. A publishing subscribing library can be used for this requirement, which would broker the view model, view model interaction. View model would receive a notification from the model, and the model would not require reference to the view model object. To read about MEVM and JavaFX, check out MEVM FX project in the documentation. The completed now we are considering stylable properties in best practices. The purpose of getClass CSS metadata is to allow classes to easily include the CSS metadata of some anchor. The interface stylable property T in package javafx.css in module javafx.graphics. Stylable property allows a javafx.beans.property to be styled from CSS. The JavaFX property can be stylable properties in Java. A JavaFX property can be styled via CSS by using stylable property. This is useful when controls need properties that can be set via CSS. In order to use stylable property on a control, one need to create a new CSS metadata using stylable property. The CSS metadata is created for a control needs to be added to the list CSS metadata. Obtained from the controls ancestor. This new list is then returned from the get control CSS metadata. By conversion, the control class that have CSS metadata will implement the static method get class CSS metadata, and it is customary to have get control CSS metadata simply return get class CSS metadata. The purpose of get class CSS metadata is to allow subclasses to easily include CSS metadata of some ancestor. Creation of stylable property and CSS metadata needs a lot of a boilerplate code, and this can be reduced by using stylable property factory. Stylable property factory contains a method to create stylable property with corresponding CSS metadata. Here stylable property, typical JavaFX property implementation. CSS metadata, fetch CSS metadata from its ancestors. A new CSS metadata. Return all CSS metadata information. Stylable property, typical JavaFX property implementation. Stylable property factory, CSS metadata from stylable property factory. Return all CSS metadata information from stylable property factory. Now we are considering overview in introduction to FXML. FXML is a scriptable XML based markup language for constructing Java object graphs. It provides a convenient alternative to constructing such graphs in procedural code and is ideally suited to defining the user interface of a JavaFX application, since the hierarchical structure of an XML document closely parallels the structure of the JavaFX scene graph. Now we are considering instance declarations. Uh, in class instance elements, in elements, if an elements tag is considered an instance declaration, if the tag begins with the uppercase letter and this and the class is imported, here the following is a simple but complete example that creates instance of JavaFX.scene.control.label and sets its text property to hello world. The class label in package JavaFX scene.control in module JavaFX.controls. Label is a non-editable text control. A label is used for displaying text that is required to fit within a specific space, and thus may need to use an ellipsis and or truncation to size the string to fit. Labels also are useful in that they can have a mnemonic which, if used, will send focus to the control listed as a target of the label for property. And if an element tag is considered an instance declaration, if the tag begins with the uppercase letter and the class is imported, or as in Java, it denotes a fully qualified, including the package name of a class. When fxml loader, also introduced later, encounters such an element, it creates an instance of that class. Importing a class is done using import processing instruction pi. For example, the following pi imports the JavaFX .scene.control package into the following pi imports the JavaFX.scene.control.label class into the current fxml documents namespace. If we put asterisk here, that will import all the classes from JavaFX scene.control package. Any class that adheres to Java Bean constructor and property naming conventions can be readily instantiated and configured using fxml. The following is a simple but complete example that create an instance of JavaFX.scene.control.label and set its text property to hello world. Note that label's text property in this example is set using an XML attribute. Properties can also be set using nested property elements. Property elements are property attributes. Classes that don't conform to Bean conventions can also be constructed in fxml using an object called a builder. Now we are considering instance properties. In attributes, when the following markup is processed, x, y, width and height values will be converted to doubles, and the fill property will be converted to a color. The class rectangle in package JavaFX.scene.shape in module JavaFX.graphics The rectangle class defines a rectangle with a specified size and location. By default, the rectangle has sharp corners. Rounded corners can be specified by setting both the arc width and arc height properties to positive values greater than 0.0. Like property elements, attributes can also be used to configure properties of a class instance. For example, the following markup creates a button whose text reads click me. As with property elements, property attributes support type coercion. When the following markup is processed, x, y, width, height values will be converted to doubles, and the fill value will be converted to a color. Unlike property elements, which are applied as they are processed, property attributes are not applied until the closing tag of their respective element is reached. This is done primarily to facilitate the case where an attribute value depends on some information that won't be available until after the element's content has been completely processed. For example, the selected index of the tab pane control, which can't be set until all of the tabs have been added. Another key difference between property attributes and property elements in FXML is that attribute supports a number of resolution operators that extend their functionality. The following operators are supported: location resolution, resource resolution, and variable resolution. Under this topic, we can discuss these operators. Now we are considering scripting. The following example markup defines a function called handle button action that is called by the action handler attached to the button element. The JavaFX colon script tag allows a caller to import scripting code into or embed scripting within FXML file. Any JVM scripting language can be used, including JavaScript, Groovy, and Clojure, among others. Script code is often used to define event handlers directly in markup or in an associated source file, since the event handlers can often be written more concisely in more loosely typed scripting languages than they can be statically typed languages such as Java. Note the JavaScript script engine is disabled by default. If the JDK has a script engine, JavaScript script engine, it can be enabled using a system property javafx.allowJS equal true. Scripts are compiled by default when they are first loaded if the script engine implements javafx.script.compatible interface. If the compilation fails, the FXML loader will fall back to interpreted mode. Note, to run off the automatic compilation of script code, place the processing instruction compile false before the script element. To turn on the compilation of script code again, use processing instruction compile true or short compile. The compile processing instruction can be used repeatedly to turn compilation of the script code off and on. The following example markup define a function called handle button action that is called by the action handler attached to the button element. Clicking the button triggers event handler, which invokes the function producing output. Script code may also be defined in external files. Now we are considering controllers. As shown here, controllers are often used to implement event handlers for user interface element defined in the markup. While it can be convenient to write simple event handler in a script, either inline or defined in external files, it is often preferable to define more complex application logic in a compiled, strongly typed language such as Java. As discussed earlier, the fx controller attribute allows a caller to associate a controller class with the fxml document. A control is compiled class that implements the code behind the object hierarchy defined by the document. The controllers are used to implement event handlers for user interface element defined in the markup. In many cases, it is sufficient to simply declare event handlers in this manner. However, when more control over the behavior of the controller and the elements it manages is required, the controller can define initialize method, which will be called once on implementing controller when the controller is when the content of the associated document have been completely loaded. Now we are considering at fxml. For example, the controllers from the previous examples could be rewritten as follows. The annotation interface fxml in package javafx.xml in module javafx.fxml. Annotation that tags a field or method as accessible to markup. Note that in the previous examples, the controller member fields and event handler methods were declared as public, so they can be set or invoked by the loader. In practice, this is not often an issue since the controller is generally only visible to the fxml loader that created it. However, for developers who prefer more restricted visibility for controller fields and or handler methods, the JavaFX.fxml.fxml annotation can be used. This annotation marks a protected or private class member as accessible to fxml. If the class being annotated is in a named module, the module containing that class must open the containing package to at least javafx.fxml module. For example, the controllers from previous example could be rewritten as follows here. In the first version, the handle button action method is tagged with fxml at fxml to allow markup defined in the controller's document to invoke it. Now we are considering fxml loader. The type of the root element is assumed to be the subclass of JavaFX .scene.layout.pane, and the document is assumed to be assumed to define a controller type, define a controller of type myController. The class fxml loader in package javafx.fxml in module javafx.fxml. The class fxml loader loads an object hierarchy from an XML document for the fxml loader class is responsible for actually loading an fxml source file and returning the resulting object graph. For example, the following code loads an fxml file from the location on the class path relative to the loading class, and localizes it with the resource bundle name com.foo.example. The type of the root element is assumed to be class of to be a subclass of javafx.scene.layout.pane, and the document is assumed to define the controller of type myController. Note that the output of an fxml loader #load method operation is an instance hierarchy that reflects the actual named classes in the document, not org.w3c.dom nodes representing those classes. Internally, fxml loader uses the javafx.xml.stream API, also known as streaming API for XML or STAX, to load the fxml document. STAX is an extremely efficient event-based XML parsing API that is conceptually similar to its W3C predecessor, SAX. It allows an fxml document to be processed in a simple pass rather than loaded into loaded into an intermediate DOM structure and then post-processed. Now we are considering deploying an application as a module. For example, if com.foo.myController is in the foo, is in the foo.app module, the module -info.java might look like this. The fxml loader is used to load types in a named module. The application must ensure that all types are referenced in the fxml files, including the controller class and any custom node classes, are reflectively accessible to the javafx.fxml module. A type is reflectively accessible if the module opens the containing package to at least the javafx.fxml module. For example, if the com.foo.myController is in the foo.app module, the module info.java might look like this. Alternatively, a type is reflectively accessible if the module exports the containing package unconditionally. Now we are considering examples in introduction in contents in JavaFX CSS reference guide. Without any styles, this will display a plain black rectangle. If test.css contains the following, the rectangle will be red instead of black. To consider the following simple JavaFX application. So without any styles, this will display a plain black rectangle. If test.css contains the following, the rectangle will be in this test.css here. The rectangle will be red instead of black. Now we are considering a warning example. For example, this one. When a JavaFX CSS parser encounters a syntax error, warning message is emitted, which conveys as much information as available to help resolve the error. For example, this one. Warning JavaFX CSS parser declaration expected % while passing -fx background -color at $149. The cryptic $149 pertains to a location of the error. Format of the location is URL, line, and position. If the error is found while passing a file URL will be given. If the error if the array is from an inline style, as in the example here, URL is given as a question mark. The line and the position give an offset into the file or string where the token begins. Please note that the line and position may not be accurate in releases prior to JavaFX 2.2. Applications needing to detect errors from the parser can add a listener to the errors property of the javafx.css.css parser. Now we are considering URI in types. Address is an hierarchical URI of the form scheme colon authority and then path, like here, for example here. if the address does not have scheme component, the address is considered to be the path component only. The leading / character indicates that the path is relative to the root of the class path. If the style appears in a style sheet and has no leading character, the path is relative to the base URI of the style sheet. If the style sheet appears in inline style, the path is relative to the root of the class path, regardless of whether or not there's a leading / leading /. Note that inline styles, for inline styles, the leading dot dash segments dot do resolve, since the path is always anchored at the root of the class path. As an example, the code snippet below creates a scene filled with fictional duke.png image located in an image directory. The same style would work equally as well from a style sheet. Now we are considering group in JavaFX .stage in stage. Style class root popup. Pop-up window does not have any properties that can be styled by CSS, but pop-up window does have its own scene. Scenes root gets the .root style class by default. If the scene is the root scene of the pop-up window, then the .popup style class is also added. This allows the root scene of the pop-up window to have distinct style via the CSS rule .root .popup open curly brace, then declarations and close curly brace. Now we are considering available CSS pseudo classes in pseudo classes. So CSS pseudo class disabled applies when the disabled variable is true. Now we are considering accordion. In JavaFX.scene.control in controls, the style class accordion. The accordion control has all the properties and pseudo classes of control. Now we are considering area chart. In JavaFX.scene.charts. In charts, the style class chart series area line series I default color J, where I is the index of the series and the J is the series color index, the properties node. Here you can see hello app.class in overview in scene graph. One possible implementation that will produce a scene graph matching the figure above is as follows. The class scene in package JavaFX.scene in module JavaFX.graphics. The JavaFX scene class is the container for all content in scene graph. The background of the scene is filled as specified by the fill property. The result of running the code is seen in this figure. The important notes: the node can have maximum one parent. A node is the active attached to the currently visible scene, the scene graph. Can only be modified from the JavaFX application thread. Now we are considering translate in transformations. We will use the we can translate the box here by 100 pixels in x-axis and 200 pixels in y-axis. You can see the translated figure here. The public final void translate x double value defines the x coordinate of the translation that is added to this node's transform. Here y. This is in the class node. This method is in the class node and in the package JavaFX.scene, in the module JavaFX.scene, JavaFX.graphics. Now we are considering event handling. Let's create a custom event. The class event, which is in package JavaFX.event in module JavaFX.base. The base class for FX event. Each FX event has associated an event source. Event target and event type. The event source specifies for an event handler the object on which that handler has been registered and which send the event to it. The event target defines the path through which the event will travel when posted, and the event type provides additional classification to events of the same event class. An event notifies that something important has taken place. Events are typically the primitive of an event system, also known as event bus. Generally, an event system has the following three responsibilities: fire, trigger an event, notify listeners notify listeners, interested parties about the event, and handle process uh, the event. An event notification mechanism is done by the JavaFX platform automatically. Hence, we will only consider how to fire event, listen for events, and how to handle them. Let's create a custom event here. Since event types are fixed, they are usually created within the same source file as the event. We can see that there are two specific types of events: logging succeeded and logging failed. We can listen for such specific types of events. Alternatively, we can handle any event if you put here .any. Finally, we are able to construct and fire our events. For example, login succeeded or login failed could be fired when a user attempt to log in to an app. Depending on the logging result, we can allow the user access the app or lock him out of the app. Whilst the same functionality can be achieved with a simple if statement, where there is one significant advantage of an event system. Event systems were designed to enable communication between various modules subsystems in an application without tightly coupling them, such as a sound might be played by an audio system when the user log in, thus maintaining audio related code in its own module. However, we will not delve deeper into architectural styles here. Any other fields of importance, for example, data timestamp, handle event, Now we are considering timing. The following is the Java class of the demonstration program. It is important to understand the timing difference between creation of JavaFX UI controls and the display of the controls. When creating UI controls, either through direct API object creation or through FXML, you may be missing certain screen geometry values such as dimension of a window that is available later at the instant when the screen is shown to the user. That showing event called onShown is the time at which a window has been allocated and final layout computations completed. To demonstrate this, consider the following program, which displays the screen dimensions while the UI controls are being created. um, and the screen dimensions when screen is shown. The following screenshot shows the running of the program when UI controls are being created. A new VBox a new scene. The primary stage dot set scene. There are no actual window height and width values available, as evident by the undefined n values. However, the values for the width and heights are available once window is shown. The program registers an event handler for the unshown event and prepares the same output. The following is the Java class of the demonstration program. Sometimes you will know the screen dimensions in advance, and you can use those values at any point in the JavaFX program. This includes before the unshown event. However, if your initialization sequence contains a logic that needs these values, you will need to work with the unshown event. A use case might be working with the last saved dimensions, so the dimensions based on program input. Before show method, I just see this to just set this to 480 multiplied by 320, right? All available now. we can consider this error, access restriction. The type application is not API restriction on required library rt.ja. This occurred in the environment of with JavaFX and Eclipse. As an error example 2, we can consider this error occurred in JavaFX 8. Error 3525 Java method getSeen in class JavaFX.stage.window cannot be applied to given types. Required no arguments. Found JavaFX scene.scene reason actual and formal argument list differ in length.